I'm Alice from House of ZK, really excited to moderate this debate between Uma from Succinct and also Zac from Aztec. Our goal today is to really try to flesh out the advantages and then also the limitations between these two approaches, zkVMs and zkDSLs, and really help members of our audience navigate through these kinds of trade-offs and see which one is more suitable for your needs, depending on what you're trying to build.
Oh, the mic's on. Sorry for interrupting. I don't think the microphones are on.
Oh,
yeah, no worries. Sure. I could also hold it if that's okay. Yeah. Okay. Yeah, okay, sounds great. All right, so I'm wondering if we can first start off with maybe some of the advantages that come with both approaches. So if you want to speak of some of the advantages that come with zkVMs, and then Zac, if you want to speak of some of the advantages that come with zkDSLs, and then also address some of the limitations that come with each approach.
Yeah, I can start. So for a zkVM, what is a zkVM? Basically, what we're building at Succinct is a zkVM called SP1, where you can just take normal code like Rust. It gets compiled to RISC-V, which is a pretty standard instruction set, and then we can prove the execution of any RISC-V program. So I think the biggest benefit is that the developer experience is like as if similar or the exact same as normal programming. Like there's 2 million developers that know Rust. There's probably like hundreds of people that know like esoteric ZK languages and stuff like that. So it's just like orders of magnitude better developer experience. And then another benefit is that there's so many libraries and tooling built out in Rust already. So for example, the JSON library, the third-A library, even like node implementations like ref and revim, or even light client implementations like Tendermint that are all written in Rust. And now you can get all of that tooling and library for free, basically. And that's what I see is like the reason why I think zkVMs are just gonna like dominate all of ZK for the next, or for like basically the rest of time.
Yeah, hey, I guess I'll represent the DSL side now. So a zkDSL is one where you have a bespoke programming language, domain-specific language that compiles down into a ZK circuit. And the big difference between that and a VM is, for a zkVM, you have basically one circuit, one proof system, which will simulate a virtual machine and verify a program trace. Whereas with a DSL, you can directly compile your program into like the most optimal constraints for your proving system. The reason why we went down this approach with Noir is because with privacy, with a focus on privacy, it's important to be able to prove your statements locally on very limited hardware. So, phones, old laptops. And there you have some severe resource constraints. You have resource constraints, particularly with regards to memory as well as computation. And so the efficiency that you can leverage from directly transpiling your program statements into constraints without going through the VM abstraction for us is extremely useful. The way I think about it is, before I say that, I'll go with some of the downsides, which is I think what Uma has kind of mentioned, or the corollary to that, which is that with Noir you don't. It's pretty easy to program and it's Rust-like. It's not Rust. You don't have access to this existing ecosystem of software and libraries, and so the question about whether that's acceptable, I think it's very much depends on where on the trade-off space you are. Because, and again, I think what's quite telling is with SP1 and with Aztec, like we have quite different focuses. Where SP1, correct me if I'm mistaken, the main focus is on computational compression. Basically, can you take a very, very complicated statement and prove it, construct a proof that you can verify very, very efficiently, so that you can do things like scale blockchain. Or you can have an untrusted prover with a lot of resources. They use to prove a statement that you then verify with a trusted entity that has very few resources. which is a blockchain basically. For privacy, things are very different, because if you're building a private transaction layer like network like Aztec, the programming paradigm is quite radically different. You're working with encrypted state models specifically, and having to manipulate and update private state, it's quite challenging. You have nullifiers, you have UTXOs, and we wanted to create a DSO where you can provide semantics that abstract away that complexity, have that kind of that ability to fine tune that. And similarly, I think what we're doing with Aztec very much mirrors what's happened in the Web3 ecosystem, where solidity, for example, wasn't much of a barrier to adoption to blockchain. If anything, quite the opposite. Historically, blockchains with programming languages that are exactly the same as existing ones, like Rust, don't seem to have a huge amount of value add compared to ones we have to learn a new domain language like Solidity, because basically there's already so much to learn if you're writing a smart contract coming from a programming background. The actual overhead of learning a new language is relatively minor, because if you have a bug in a Solidity smart contract, you can lose millions, billions of dollars. It's a very different model to regular programming. So anyway, that's a very long-winded explanation, but the crux of it is resource limited. If you have resource constraints and you need to maximize all available performance, compiling directly into constraints will create a faster proofs than running through a VM.
Mm-hmm. So Zac, you mentioned that zkDSLs may be more advantageous if you have those kinds of limited resources, and Uma, you mentioned that the developer experience is going to be a lot more simplified when using a zkVM. I wanted to dive a little bit more into the developer experience part. I know that both of you, both Aztec and Succinct, is focused on trying to abstract those cryptographic complexities away and having the developer really focus on the logic behind their application rather than just writing the circuits directly. But just wondering what is really needed for a developer to build their zk application in both the short and long term. How I personally see it is that zkVMs can be particularly useful when a project is about to, when they're trying to bootstrap their product, but then maybe later down the line when they're focused on optimizing for performance, maybe zkDSLs can come in. So wondering about how the developer experience would be affected in both the short and long term, and maybe some differences in terms of the incentives that are offered on zkVMs and then also on zkDSLs.
I guess I maybe kind of disagree that people are going to move off of zkVMs even as their project becomes more mature. And I think, okay, for example, let's look to AI, where today a lot of people bootstrap their application by using like the GPT-4 OpenAI API, but actually a lot of them don't end up moving off because it's actually hard to like train your own model to compete, because the model itself, it has so much going into it. It has, so much optimization, it has so much data that it actually, it's very hard to compete with that by doing something yourself. And I actually think the zkVM paradigm is really similar. So even earlier, I was like talking to a team where they had built their own zkEVM from scratch, like a circuit for it. And my understanding from talking to him briefly is that their costs aren't even competitive with running ref and revm in SP1. And that's actually like really surprising for a lot of people, because for SP1, it's like the developer experience is so good, right? You can just stick ref, a Rust binary in SP1, prove it, and the developer experience is amazing, and it's also really cheap and fast. So it kind of feels like you're getting free lunch in some sense, because it's just better in like every dimension. But I think the intuition behind that, once you like dig a little deeper into it, makes sense. Basically with SP1, it has like such a good paradigm for programming where it's this platform where, because it can support any Rust code, it compounds like a lot more than hand writing circuits for a bunch of different applications and like doing custom optimizations for a bunch of different applications. And in particular, there's something in our approach called precompiles, where we actually get kind of like the 80-20 of optimizations with this approach, which I'll go into a little bit. I believe Noir also kind of has like these precompiled circuits in a certain sense, like for your big-in RSA stuff.
We have some custom gates. I wouldn't really call those precompiles though. They're just slightly different ways of expressing constraints.
Oh, I see. I think I remember that I saw some Twitter post that you.
We have a VM, which could be considered a precompile, but it's not really part of the Noir cryptography engine. Basically, if you want to do recursion folding in Aztec, then we delegate expensive operations to the very end of your transaction life cycle, where we then prove those with a custom virtual machine, which could be considered a form of precompile.
Yeah, it sounds maybe somewhat similar to what we do, but basically for our case, like, let's take a really illustrative example. So for an Ethereum block, if you just run it in like normal RISC-V, it's around like 2 billion RISC-V cycles, which is quite a lot. But we have these like specialized circuits for Ketchak, for SecP256K1 signature verification, for SHA-2, and a bunch of other things. And if you use these custom circuits with SP1, and we have this architecture that lets you kind of interleave like normal instructions with these custom circuits, you get down to like 200 to 300 million cycles. So that's basically a 10x reduction in the amount of net prover work. And I'm being a little imprecise here, but you can roughly think of it as an order of magnitude reduction. And you can see that like from this approach, we kind of get the biggest benefits of custom circuits while still being able to maintain this like developer flexibility. And I think that's kind of the intuition why it's actually really hard for another team to compete with that, because if they did a bunch of custom circuits, well, first of all, they'd have to recreate all our custom circuits for Ketchak and SHA and all that stuff. But imagine you did that. Then if you want to custom circuit all the other parts, you're only getting like a small fraction of the gains, because we already got most of the gains from like our precompiles that are the most commonly used. So I think that provides an intuition for why I actually think projects aren't going to move off of zkVMs, and instead they're going to always continue using zkVMs, because our team's also always focused on making our zkVM better, and it's really hard for another project to like keep up with those advancements in general.
Could I touch on that? Because I feel like I want to push back against some points there, because what you described, that process of like the other team building an zkVM and not being able to compete against SP1, what I see there is just you have what you're describing is your moat against other zkVMs, which I think is slightly different to competing against a zkDSL approach, and I think it's quite difficult to. What I'm going to talk about is quite abstract, because right now today I feel like the ZK space is still extremely immature and underdeveloped compared to what it's going to be. So what I'm going to talk about doesn't exist today, but I want to project a few years into the future, maybe 10 years, where I feel like the precompile approach kind of is going to be, my prediction, slightly problematic, because basically the brute force RISC-V approach, when you want to run pretty complicated programs, right? Like it's not optimal. This is why the precompiles exist. But the precompiles you talked about, they exist for Ethereum, right? So if you want to verify an Ethereum block using SP1, great, you have precompiles. But what if you want to do something else? You know, what if I want to verify a machine learning algorithm? What if I got some like really complicated trade matching engine that uses some like weird algebra? What if I don't know. What if I want to run like if I want to verify that my nuclear reactor software is running properly? Basically, the larger the industry gets, the more complexity you're going to get, the more diversity of applications you're going to get, and the harder it's going to be to maintain precompiles to make sure that the VM will always remain state of the art. I would have a lot more confidence that VMs will dominate if the VMs didn't need precompiles. And there's an open question about, will that ever be the case? Quite possibly. The way this space is moving, quite possibly. But I think it's a little too early to say. Here's what I want to discuss or think about. What we're seeing in the space is, it's growing. There's a lot more capability to handle complexity. Right now, the limiting factor generally, if you're trying to do something in this space, is developer time, because good developers, they are six-figure salaries, easy 6 figures, right? And so you need to minimize the amount of time you're spending executing. And so a VM abstraction is fantastic for that. You build your virtual machine that can handle any program, and then you can focus your limited developer resources on optimizing that VM, and then companies downstream from you, they can just use your VM. And I think that similarly, this is kind of why I think the dynamic for why VMs proliferated in the real world, right? Because if I want to, who writes web apps in C++, or even Rust, right? Because just the different compilation targets for all the different devices that you're executing it on, it's an absolute nightmare. It's much easier just to say, okay, Chrome, Safari, you handle it. You write a JavaScript virtual machine. I'm just going to code in JavaScript. But what's going to happen longer term? As effectively, the more people come into the space, the contentious resource stops becoming developer time, right? Because the products are more, the products have larger audiences, they generate more revenue. The value you gain in extra performance outstrips the resources that you're willing to, that it will cost to pump into it to get that performance. I do think there's going to be an inflection point somewhere where basically, if one had arbitrary resources, right, and you wanted to make a maximally efficient ZK system, what would you do? Well, you would take a language like Rust, and you would write your own compiler, right? You would replicate all of the work, the 20, 30 years of work that's gone into Clang and LLVM, and you do it all again from scratch. And you would write a compiler which compiles down into an intermediate language which is optimized for ZK circuits, and then that compiles directly into optimal constraints. Now that approach, if one could build that, it would blow the zkVM out of the water. But obviously, what I'm talking about is requires a lot of developer resources that no sane person is willing to invest now because it's just not worth it. But I would wager that if we succeed, like the happy path is if this industry succeeds and ZK becomes eats the world, then that is exactly what's going to happen.
Yeah, I guess I'm pretty in agreement there that maybe one day there will be a compiler layer that gets written. But I think, and it sounds like maybe we are even in agreement that the general purpose front end that's normal code is here to stay. But I guess I don't see why we can't even write the compiler. Once we have more usage and then we're oh yeah, now the next part of the stack to optimize is the compiler layer.
Yeah, you could, but it wouldn't be a zkVM then.
On I guess a very technical level, totally. But then it has the property that most people care about as zkVM, which is I can just write Rust.
Yeah, so you're talking about natural languages versus DSLs there, which I think I do wonder. I think it depends on what it's used for. If you're doing computation compression, absolutely, nobody wants to learn a new language. What's the point? I do feel if you're caring about privacy, right, you want to say you're building some application where you have a client, you have a server, and the client is holding back information from the server and sending proofs of knowledge instead. Then things get a lot trickier because existing programming languages don't really have semantics or heuristics that kind of make that easy, right? No one's designed it like that. And okay, sure, maybe you could write libraries to do that, but you definitely could write libraries to do that. But the more your programming environment depends on those libraries and the interface and the API, A, the more cumbersome things become, and B, the less your program looks like a Rust program, the more it looks like something else entirely. And I think for Aztec, because our focus is very much on programmable private smart contracts, because the smart contract programming domain is so weird and unique. The execution environment of a blockchain is so unique. We felt that, if we did say you could write, imagine we couldn't do this just because the performance wouldn't be good enough for client side. But let's say we say okay, right, you can write your Rust code, and we'll turn that into a proof that you can prove locally. The amount of library additions and weird extra extensions that you would need to actually handle contract semantics, to handle private state, to handle storage would be so high that really that would be the majority of your code at that point. And so it wouldn't really be Rust anymore.
I guess doesn't Solana has a Rust front end that then compiles to eBPF, and then they have their own libraries of their own 6 canonical smart contracts that they expect people to use. So I guess why do you feel and clearly they're pretty successful. So
they're successful, yeah, but I also think that programming Solana is not really like programming Rust.
Yeah, totally.
I wouldn't say it's a deal breaker. It's just that it's not. You lose the value add. If I think about Solana, I don't think Solana's value prop is I can write my smart contracts in Rust. The value prop is it's fast and it's low latency and it's cheap.
Yeah, but I guess at the same time, you still get nice, like, the cargo package manager, like, you still, like, your ID, like, you know, recognizes, you know, shows Rust Analyzer and stuff like that. So, but I do agree with you that that's definitely not Solana's main value prop is, oh, you can just write Rust, because it is a really different semantics and paradigm, and you have to understand so much stuff. But there is, I think, some non-trivial benefit to all of the tooling that you can get. Like, cargo is pretty nice. You know, Crates.io is pretty nice. Like, all that stuff is pretty nice.
Yeah, you're right about that. And there is a trade-off there. And, you know, like, it is very hard to build a good package manager like Cargo. It's very hard to build, like, good formatters, good language servers.
Yeah.
But you know,
AI, like...
But can I finish? But, like, you know, our team is pretty stacked because we have all of that. And we've got profilers, and we've got... like Nargo is, okay, sorry, I'm shilling here. I'm going to shill a little bit. I'm always blown away by Nargo, and like just how easy it is to update to the latest version, to modify versions, basically like to pull down libraries that other people have written. Yeah, I know I'm shilling, but you know, I wasn't involved in that part of, you know, I operate at a high level of the stack these days. So just when I was writing Noir code last week and going, how do I like update to the latest pre-release to get certain weird supports? It was really easy. I was expecting about like 2 hours of work installing weird libraries. So yeah, tooling is a big deal, and it is a pain in the ass to recreate it all from scratch.
I guess also the AIs these days have been trained on like mountains of Rust code and stuff, but maybe, you know, you can get them to train on mountains of Noir code too.
Yeah, it's surprisingly good actually with the Noir code. But also, I hate to be like a cynic or like a curmudgeon, but I also feel like when it comes to smart contract programming, I would worry about AI. You know, if you're like, write me a Solidity smart contract like to do a DEX, you know, like that's you're going to be getting a digital knock on the door from North Korea, I think.
But I mean, to push back on that a little bit, you can also have like the AI auditors like audit my DEX too, and like for example, they've seen like so many Solidity hacks and bugs that actually I was trying out O1 Pro recently, even on like some of our own stuff, and it was pretty good.
Yeah.
At detecting things.
Yeah, I agree with that. But also, like, if that was something we could optimize for, we'd probably choose Solidity as a target language, not Rust, because of the training data on like all the hacks that cost lots of money are on in Solidity. So I know this is a big tangent, but I find it like just beautifully ironic, right? That like Solidity as a language, right, is very, very insecure. As in, if you were going to design a smart contract programming language from scratch, knowing what we know now, like Gavin Wood did a great job back in 2014, knowing what he knew. But knowing what we know now, you wouldn't dream of doing it as Solidity. Nevertheless, if you're going to write a smart contract today, like the safest language to do it in is Solidity, just because of the sheer amount of knowledge that we've attained about best security practices and that knowledge has been paid for in cash through all the hacks that have happened. But yeah, I just find it funny that Solidity is kind of the safest language to write smart contracts in. Ish.
Yeah, so we talked, you guys both talked a bit about performance, about tooling, about the developer experience. I'm very curious to hear more about the security side. So in adding more of these abstraction layers on top of circuit building, does this potentially introduce any kinds of new security vulnerabilities? Or does adding these abstraction layers maybe reduce the number of bugs that a developer may unintentionally write?
I think with both Noir and a zkVM, it actually helps the security situation quite substantially, because instead of having random developers ape-in whatever circuits that they came up with that month and like shipping, you basically have a standardized interface, and then the security critical code is all in one repo, it's all in one place, it's maintained by like a highly competent team, it's reviewed and audited many times, the security compounds over time. So I actually think both zkVMs and zkDSLs are like a huge improvement than developers rolling their own zk.
Yeah, writing your own zk circuits is someone who's done it. It's you can do it, but it's you're gonna have more bugs than if you use an abstraction layer. As much as I'm supposed to be repping my side, I do think here that the zkVMs actually they are easier to secure. because the attack surface of bugs is smaller. Take a zkDSL like Noir. You have unconstrained functions, right? Because often performing a computation is more expensive. Proving a computation is more expensive than verifying the computation. Like the classic example is if you want to validate that 1 over x equals y, divisions are expensive, right? So what you do instead is you check that x times y equals 1. And that basically means that in Noir you can use unconstrained functions to generate witnesses and then constrained functions to prove that the output is correct, which basically means you're exposed to the underconstrained class of bugs, which you don't get in a VM, and that class of bugs is quite large. So again, I think it's one of these things where if you want to squeeze out performance, there's a trade-off space. The more performance you get, like the less the abstraction layer is going to hold your hand, and the more you can shoot yourself in the foot. So I feel like there's a kind of like hierarchy where if you're writing your own circuits, you're playing with a loaded shotgun with a hair trigger and no safety, and zkDSL a lot more secure. As Uma said, the code's all in one place. You just verify your Noir code. You trust that the actual Noir compiler and the backends are all being audited by the best people in the industry. The surface that where things can go wrong is much smaller. But I do think zkVMs as well as it's probably a little easier to validate your code.
Got it. And in terms of some of the future use cases that we're anticipating, a lot of projects in ZK space were anticipating near real-time proving sometime in the future. There's a lot of talks about Starkifying Ethereum. And then I know both Succinct and Aztec is really, in terms of use cases, really excited about, for example, private voting. Now, in powering these kinds of use cases for the future, is there an approach that you both personally believe may be more preferable over the other, or do you anticipate maybe a combination of these approaches being used depending on the type of use cases we're thinking about?
I guess I think in the next year or two, there's actually a really clean place where you should use a zkVM versus a zkDSL. So for example, I think if you're doing client-side proving in the browser or in your phone, I will be the first to admit Noir probably crushes us. Because SP1's performance is really, we get a lot of great performance from GPUs, but your browser doesn't really, they don't really have that. They have web GPU, but it's not really there. Or your phone, if you have an Android phone, it's just a really hard situation for SP1 to perform well. So I think there's a really clean divide. It's if you want it on a mobile device or your browser, use Noir. If you want anything else, I think SP1 is really great. And I feel all the use cases you guys are targeted are actually oriented around those environments for proving. So it's actually, I feel in some ways we actually don't even disagree on where the people should use one or the other. I think, for example, for real-time Ethereum proving, that's one of our biggest use cases that we personally at our company even care about. And so we're really focused on optimizing for it, from our precompiles to even optimizing the Rust code that lives on top, to even optimizing the parallelized proof generation across a bunch of hardware. So I think that will be a clear winner for that use case, just because we're so focused on it and so focused on that and roll-up workloads. Whereas I don't imagine that you guys are thinking about or that focus on that kind of stuff.
On real-time proving?
Yeah.
No, I hear all the chatter about it online, and I just get very jealous and bitter because it's what you were saying. With when you're doing computation compression, right? You can hit the scale button, right? You focus on making your code as parallelizable as possible, crushing down Armstrong's law, and then you just scale. With client-side proving, you can't scale. Maybe you could get the user to prove on their iPad and their phone at the same time, and so it's a much tougher challenge. Certainly, real-time proving client-side isn't happening anytime soon. That being said, it's the end goal for something like Aztec is to get to Web 2 style of user experience where things just do happen. But I do suspect in the medium term, that's going to require computation delegation. So basically, you get a third party to prove for you. So either a trusted execution environment or an MPC setup like Tatseo. Because real time on the client side isn't happening anytime soon unless you just want to prove a Fibonacci sequence. But yeah, I do think that the distinction is fairly clear cut. Like you can see in the difference of our cryptography engines, right? Like we don't focus on GPUs; it's purely CPU because there's not much point. Eventually, we'll get around to WebGPU, but WebGPU is, it's a bit underbaked. It needs a bit more time in the oven. If you don't need privacy, if you don't need the handle private state semantics, and you don't want to improve client side, then Noir won't be the fastest solution for you if you have GPUs at your disposal to prove. I do think the distinction is fairly clear for now. I do think that there are some interesting interesting future paths. I do think that the direct compilation path is going to eventually become dominant, but it might take a lot of time because it requires so much effort to basically build compilers from scratch. I also think another big advantage of DSLs is the fact that it creates an intermediate representation means that it's a little easier to decouple the execution environment from the proving system, because the proving systems are everything is the pace of change in cryptography research is so fast that everything obsoletes in 6 months. I would love to completely revamp Aztec's cryptography as a state of the art, but that would add 18 months, 24 months to our roadmap to release. So we're not going to do it. But the power of things like Noir is that because it can pass down to an intermediate representation, you can swap in different cryptography proving backends, which means it's possible to kind of outsource keeping up with state of the art to the entire community. There's WorldCoin, for example, building a backend for Noir using some crazy prime field stuff. So there is that advantage. I do think that once there's a bit of maturity in the ecosystem, right? Let's say we have zkVMs that are deployed, they're audited, mature, they're being used in production by a lot of systems, then there's going to be a problem where you skip forward 2 years, and now that zkVM proving technology is 5x, 10x slower than the new stuff. And completely revamping a zkVM to use new cryptography is going to be a harder thing to do than building a new cryptography library and then proving an intermediate representation. Although both are very hard. So, yeah.
And just as a kind of a last question before we close, I'm wondering for both approaches, what sort of new innovations are needed to enable for both zkDSLs and zkVMs to be more performant in industries, even those beyond Web3? And then also if you have any kinds of advice you'd like to give to anyone in the audience who is trying to navigate these different trade-offs.
I think there's still a 10x to be squeezed out of the stack from proving system improvements, better engineering across the stack, and just overall optimizations. And it's not yes, it's difficult, but it's not rocket science. I think all these things will happen, and that's what we're focused on. So I think if you combine all these things, a 10x is you have to do a 2x between 3 and 4 times, and there are 2x's everywhere. You have to remember that even with SP1, we launched it 1 year ago, and so even in the past year, we've improved its performance by 20, 30x. And we're still learning new things every day from profiling performance and optimizing. So yeah, I think 10x is very easily still on the table. I think the next 10x after that will definitely be harder, but we'll cross that bridge when it comes, I guess. In terms of advice, I think ZK, especially with zkVMs, I really think ZK is now moving out of the research phase into more of the adoption phase. And I think a lot of the ZK builders that I see, they love doing stuff that's hard. And maybe you even see this with the Noir, where they're oh, I want to work on the circuits. Oh, I want to work on the proving system. And that's really cool. But I think ultimately to build a product, there's so many other parts of the stack that are really, really difficult. For example, go to market, or making a great product, or getting users, and stuff like that. And so I always encourage builders who are excited about building with ZK, being okay, now that, for example, zkVM or Noir have made ZK easy, you should take that as a plus and focus your huge amount of IQ points on all the other hard problems that might not be as sexy, but are actually like the key points of leverage in like building a product and a business. Because like ultimately that's like the phase crypto's more actively moving into. And I think to take ZK mainstream, like that's really what we need is like people who are very, very focused on product and adoption. And now that ZK is easy, we have the tools in our toolbox to make it happen. So yeah, that's kind of like my advice to builders.
Yeah, I mean, I agree with that completely. Aztec's roots are in a startup called Creditment. That's what I originally started. It was trying to do TradFi on Ethereum, but we couldn't because we needed privacy. We wanted to build a product that we knew had there was a market for where we could beat the incumbents on price, but we didn't have the technology. So that's what we spent the last 7 years building that technology so that you can Web3 can compete with Web2, it can compete with TradFi, it can provide the same kind of guarantees that people expect. So yes, I would love it if people in this room use that technology to try and build compelling, valuable products. Noir, SP1, they are means to an end. That's all they are. They are means to ends. I hope that if we succeed, our technologies, both of them, are going to become commoditized and not considered very important in the same way we don't consider Clang to be very important. But if you got rid of Clang, right, and GCC and all the compilers, right, we all can't work. But it's just it's base level infrastructure. So yeah, I think right, 2025 is the year for ZK. It's the year for privacy, where you can where the design space of a smart contract has now been exploded. You can meaningfully prove things about yourself on chain that you couldn't before. Things about your identity, like ZK Passport. You can do payments with the Open Banking API. You can even have private shared state with Chatseo and their MPC prover. You can do DeFi, where you can have some kind of basic compliance regimes if you need them. You can touch real world assets and hold them on chain without revealing that to people, without revealing the ID checks you have to go through. You can broadcast anonymously on social media. The design space of what you can do in Web3 has shifted fundamentally, and it's still today very, very hard to build products using this new technology because it's still absolutely bleeding edge. Aztec isn't even testnet yet. We're soon, really soon. But Noir is going to be audited, this year, but it's not yet been. So, it is still early stage, but the tech is here. You can use it and actually build today, and that's something which I have desperately wanted for 7 years. So yeah, ZK good, Noir good, and in the spirit of being a good host, SP1 is also good. No, it is a very impressive piece of technology, really impressive.
Yeah, absolutely. So it's really exciting that we're, as what you mentioned, Uma, transitioning from that research stage to more production-ready systems where we're able to build real applications. And what you mentioned, Zac, kind of seeing a shift within that design space. And now we're seeing more of these privacy-preserving applications being built. So we're indeed in a very exciting time. Appreciate both of you for joining us on this debate, and hope everyone in the audience took away something in terms of navigating through these trade-offs between zkDSLs and zkVMs. Definitely a lot of opportunity in both spaces. So thank you so much, both of you.
Thank you.
Thanks for having us.
All right, amazing. So we have time for just 1 or 2 questions. If there's any questions in the audience, please raise your hand. I'll bring the microphone, and then if you could, please keep it brief because we're on a schedule. And thank you so much for our panelists and our moderator. So any questions for Zac or Uma? Yeah, okay.
Hey guys, great panel. My question is around what you were just saying, kind of how ZK 2025 is the year of ZK, building applications on ZK, but you also said, the technology obsoletes every 6 months. How do you kind of make it so that people can feel comfortable building technology on top of what you've built in that environment?
Can I just feel that first? Hello? It's a very good question. 2 things is, that's the beauty of having these abstraction layers, right? It's Aztec's job, well, Noir's job, to keep up to date with the state of the art, right? You don't need to change Noir the language to integrate with the latest and greatest tech in ZK. So the idea is, if you write your programs in Noir, Aztec network isn't going away anytime soon, right? We are we are committed to making this kind of technology mainstream, which means making sure that we're always up to date with the state of the art. Well, as up to date as can be whilst actually releasing stuff, which means that you write NAR programs today. In 2 years' time, they'll be faster because we'll have integrated the best cryptography. And the same is true, I would wager, with VMs. Oh no, there was something else to that. What was your question?
Yeah, I guess you could think of it maybe in terms of like if ASICs are important and how do you, integrate things like that when they need something that's not changing, but the space is changing so fast.
Well, I mean, for Aztec, it's a little bit more straightforward because like our focus is on programmable private transactions, right? Blockchains, which means proving client side, and I don't think ASICs are coming into consumer hardware anytime soon. So yeah, well, like at least the Aztec Foundation is probably not going to be like spearheading a drive to prove Noir on ASICs. It might happen, it's an open standard. Somebody else might need that. But generally, I think if you're building an application or product, right, like your execution environment should be relatively static, as in we wouldn't ask any people using Noir, okay, now you need to buy ASICs to prove, we're always of the mind that like you should be able to prove Noir in a CPU.
Yeah, I think the exact same thing applies with SP1. Like now, builders you can just write normal Rust code. If I don't know, Succinct goes away tomorrow, well, there's a lot of other zkVMs out there that you can use, and they will probably get better. So there's actually basically zero platform risk.
Okay, thank you so much. I know I said maybe 2 questions, but we are out of time. So please join me in thanking our panelists and moderator. Thank you guys so much.